In step 5 in the framework of hypothesis testing, you make a conclusion. So we make a decision to reject the null or fail to reject the null based on the previous step by comparing our z-test statistic to some critical value or using the z-test statistic to calculate a probability value or a p-value, which is the probability of obtaining a z-test statistic as or more extreme than the one we observed or obtained. And then we compare that p-value to a level of alpha. It is always important, however, to never stop here. Make sure to substantively interpret your conclusion. The idea is that statistical significance may not equal substantive significance. So ask yourself, does the null make sense? Because you might find a particular conclusion, it might come to a particular conclusion, but ask yourself, what is this really telling in the context of your research question? I also recommend that you calculate a confidence interval. It's usually a good idea to do this. So for a 95% confidence interval, that's equivalent to setting alpha to 0.05. And so for a 95% confidence interval for the population mean, we take our point estimate of x bar, we add and subtract z alpha divided by 2, which we locate on the standard normal distribution, and we multiply that by the standard error, where the standard error is sigma divided by the square root of n. What's interesting about this is that this conventional confidence interval, it can be viewed as a two-sided z-test, with the idea that you can reject the null if the population mean, or rather you can reject the null that the population mean equals the claimed value versus the alternative that the population mean does not equal the claimed value at that particular level of alpha if the z-interval, if that confidence interval, if it doesn't include that claimed value of the population mean. And this reflects the fact that the framework of hypothesis testing is really about consistency, right? So if that confidence interval, if that z-interval does not include that claimed value of the population mean, right, under the null hypothesis, that suggests that our data is inconsistent with that null hypothesis. And so, we would reject the null in that case, right? The key point here is that there's not just one path to our conclusion. Z-test statistics, confidence intervals, and p-values, they each tell us how consistent the data are with our null hypothesis. An extreme test statistic, so very large positive or very negative, a small or low p-value, so p-value, say, below 0.05 or less than that, or a confidence interval centered away from the null are all different ways of telling us our data are inconsistent with the null hypothesis. And each of these instances, we would reject the null hypothesis. And with that, we will do some explorations of how to really come to conclusions in the framework of hypothesis testing.